Uh, Very good morning to all of you. Guys, today our topic is ratio control and MPC. MPC means model predictive control. So we have two classes, and within this period, we will cover this portion. Okay. So let's start. First is ratio control. First topic is ratio control. Guys, what do you mean by the ratio control? Actually, say in chemical process, petroleum process, petrochemical process, or if anywhere where we need some control, the ratio of two liquids or two blends. Okay, say in normal cases, two or three ratios required. Say this is X material, this is X solution or X material. This is sorry. This is Y material and this is Z material. Say in these things we need to make this ratio say 2 is to 3 is to 4 in this type. But what happens sometimes we directly control this ratio X is to Y is to this is Z. In this way if I control this, then this blend is became 2 is to 3 is to 4. Or sometimes we are doing some controlling some first loop control, then a bigger loop. Say xy is first taken as something ratio, say a is to b, then this property is added with c, then it became 2 is to 3 is to 4. So in this way we control the ratio. But it is uh, if this is a chemical process, we have to consider very accuracy, because if the ratio is mismatch or something, some disturbance happens, then total ratio become disturbed. So this is not wanted. So for this case, sometimes we are applying some model based and sometimes we are applying feedback control system. So normal cases we are applying feedback control system. uh, for each industry there is some effluent treatment plant that is called etp. Etp, effluent treatment plant, means the wastage of this plant is, it may be acidic or something may be basic, but we have to make it neutralize, then we can dispose it into your canal, into your river, or somewhere where we dispose this. Otherwise, this wastage or disposal are not allowed to dispose at the nature. So that's why every plant we need some effluent treatment plant, and it may be liquid, it may be solid, etc. Okay, even it is gaseous. So this is a boiler. In case of boiler, there the exhaust gas, this gas was also first time, there is so many environmental protection is there. After purifying these things, then we can dispose it into the atmosphere. Okay, so here some ratio control is required for this purpose. First, this is a huge application for the etp, effluent treatment plant. And then we need some chemical process, some petrochemical process where petroleum are extract from the crude oil, etc. So first of all we are going for an example, just like a model. In your actually you have to know what is the model of these things, and then you have to write down the feature of these things. Just up to this is enough for you. So I am going to give you a practical example. You have to explain this process. Sorry, my drawing is very bad here. This is your effluent tank actually. Okay, this tank maybe contains just like a one wagon, just like your wagon, or it may be very big size. Here is some stirrup is there. This is blade so that it can circulate. It will just mix up these things. Okay. First time I am try to write down the process. Consider the process in which a feed of acidic waste water is to be neutralized by the proper stoichiometric amount of SCCO in second feed stream ratio control this proper flow of sodium hydroxide can be maintained. Okay, so this is effluent treatment plant. Here I am drawing this. Here is some acidic wastage water is coming from this plant and we have to neutralize this. So we have to design a process control where perfect ratio is controlled. Look, we are talking about automatic control system. Just write down this. Okay, this is stirrup and here from this valve some acidic material is coming. This is acid. Okay, so here we can apply some flow transmitter. This is flow transmitter, okay, because we have to measure this. And look, this stirrup is not controlled anyway. This is automatically just revolving. So whenever these acid wastes are coming, we have to apply some sodium hydroxide. That is base. That is sodium hydroxide solution. So we need another flow control, flow transmitter, FT. FT means flow transmitter. Just like write down this. This is flow transmitter. Flow transmitter means it is just giving you the information regarding how much flow is going on. It will never control the flow. Look, this is not on this valve. Okay. Yes. So we have to make something so that it can control, because this acid is not, acidic wastage is not controlled by us. So we have to apply some flow control. Means here it may be valve, it may be flow control. If you want to flow control or flow controller, then you have to apply what are the things that is valve. To control this valve, we have to apply some actuator. To actuate this, we need also a positioner, or these things are mingled in a single device. This is valve, actuator and positioner. Which position we have to actuate? Then this part are the mechanical part. This is the mechanical part. Okay, it has no ability to taking decision or automatically, but this positioner, it will give you the information to the actuator, or it is operate the actuator. Then actuator operate the valve. I am giving you some example. Valve actuator, uh, okay. And this is, so this is input, but output is given when this valve will going to the upward. Okay, so this is if this is a valve, then we need to actuate this valve. So here is some actuator is required. This is given by your electrical device. This is called actuator. Okay. There is some electrical connection is there. Whenever the current is flowing through this coil, this plunger will going to the upward, or sometimes it will going to the downward as per the supply. But this actuator can be controlled by some positioner, which will control the flow of current. So in this way, a valve system is working. There is so many valves: needle valve, ball valve, butterfly valve. Maximum where we are applying the butterfly valve, where we can control the percentage also. Okay, so this is your flow controller. Now this is not complete. Now we have to control these things. You just remember, this is the PI diagram. Okay, PI diagram. This is your controller. So it will take the information from here, input control, flow control, and here is your output. Here is your output. Here, this is the pH transmitter. PHT means PHT means pH transmitter. And here also a pH controller, PHC. This PHC will give the information to this master controller. So you can see here is three controller are there. This is PHC means pH controller. Here is flow controller, and this is the master controller. Okay, so this is working just like a master and slave. This controller is main controller. Then this is called the master controller, and this is the flow control, FC, and this is the pH control. These are pH control. That is called, these two are called slave controller. Okay, in this way they are operating this total ratio control system. This is normal block diagram of a effluent treatment plant. By this way, we can control the neutralization or the pH of this acid wastage. Okay, so guys, and this is called effluent. The output is called effluent. Okay, because the pH value is neutral. You can see this stirrup has no connection, so this is normally revolving. They are not under control. Okay guys, so if you have any question, then you may ask me. This is your simple, and if you go for the block diagram,
Sir, please scroll
listen.
little bit upward, sir.
Okay, okay. Look, this is your feedback path. Okay, this is your feedback path.
No, sir. Sir, please show the valve positioner, sir. The diagram of the valve, sir.
This is valve position. Okay, later on I will give you the clear diagram of valve positioner and actuator, because these things you have to know whenever you entered into your industrial life. Though you are in electrical branch, but you have to operate all instrumentation part, because these are the linked, total process is linked with this. Okay, I will give you the so many valve diagram, how they are actuated, and what is the positioner. You need some clear idea, just this. But whenever you entered into the industry, you can see huge, vast ocean. Whatever you are study here, say if you study one type of valve, then you can get 10 type of valves there. But you need a basic idea. Then you can treat every valve, every things. That's why I'm giving you these things of details. Okay, guys, I'm going to draw this diagram, block diagram. First, you can see this is this is input. Okay, but this input is the acidic input. Sorry, sodium hydroxide solution. Okay, this input. I am not talking about this input. Okay, it is just taking as a feedback control. Look, no controller is there, no control action is there. So input, and this is valve, and this is your FC, or you can say, give it the name of FC1. FC1. Okay, the feedback is FT. This is FT1, because in industry or piping diagram you have seen there is every nomenclature is required. Okay, this is the loop. Then this output again it is taken. This output is again taken, and it is controlled over there. Sorry. This is acid waste. This input acid waste water. Okay, going to summing up. Then again another on off control. Okay, this is process feedback is this feedback is, say you can give this pH transducer to 2. This is 2. So this is pH flow transmitter, that is 2. So this is also a loop. Okay, and totally totally there is the controlling over there, that is feedback of pH. Look, this feedback is also going to the main controller. Okay, this main controller. Okay, again this PHT2 and so this FT also should be included. Sorry, it will be not there. This is direct input because you know that this FT is only given here. So this is the input FT. It is coming from FT. This is this three. This is not as a feedback. This is the input signal for this purpose. Okay, so this is the total ratio control group. This is the main control. This is the slave one, slave two, and ultimately it will control the output. Okay, so guys, if you have any question, then you may ask me. Yeah, step by step. Look, here is a one control loop is operating. Here is also one control loop is operating. Look, this is the PHC means one controller. It is taking the feedback from this portion. Okay, and you can write in another way also, and it is communicating with this controller also. It is communicating with this controller. Dotted line means this is communicating in internet or ethernet in this way, and it is direct control. So in this way we can draw this diagram step by step. Okay guys, if you have any question then ask me, otherwise I am going for the MPC control, model predictive control. So let's start with model predictive control. Guys, you have seen that is Tesla car or the something that is electronic car. Okay, but these car are generally automatic car. Automatic means this is uh, they are their claim that this car never lost its balance. Okay, this car never lost its balance. So whenever any bank is coming, the car is moving j- so smoothly that that passenger could not understand that is moving. No jerking or very less jerking, less tilling is occurred here. So how this is possible? This is done by this model predictive control that is called MPC. Today we will discuss regarding this. You may ask something or you may say something about your experience whenever car is just banking or something, whenever car or your bus is just suddenly stop, suddenly break, then some jerk you can feel. But in this electronics car, this model predictive control action is applied so that very less jerking, very less tilling, and loss of balancing is not occurred. Okay, so this is done by model predictive control. Okay, so MPC, you can write down this. This is a very new model and application is very advanced. Is a feedback control algorithm use a model to make prediction about future of the process. Okay, it is also known as di- DMC, dynamical matrix control, GPC, generalized predictive control, and another thing is RHC, that is reducing horizontal control. Is also known as DMC, that is dynamic matrix control, GPC, that is generalized predictive control, and that is RHC, reducing horizon control. Okay, so in this way, and what are the algorithm control on algorithms are used? That is, guys, okay, time is less. That is, first one is optimization problem at each step. Okay, guys, what do you mean by this optimization? Optimization means if uh, there is a choice, best choice. Say you went to a TV TV shop, you want to buy some TV, buy one TV for you. Say this is X TV. Their features is that that is a Y TV. That feature is that is a jet type of TV. Okay, this is cost is very less. For the cost effective, that is X, Z, and that is Y. For your quality, quality is that is Z, that is X, that is Y. Okay, and the features that is Y, that is that is Z, that is X. So you can see you have to consider these three things. Then you have to choose the best option which is suitable for you. This process is called optimization. It is not a straightforward thing that you just pay high money and get all these things within jet. No, sometimes jet is very cost effective, sometimes the quality of the Y is high, sometimes features is X is high but Z and Y are less than this. So you have to choose as per your choice, as per your requirement. So these things is called optimization. Okay, you can see optimization means your best selection or the best choice on your requirement. So each step it will optimize, and then the constraint optimization. Okay, it is called QP or LP. And receding horizon control. Okay, this is the control algorithm. And guys, this is just 1 minute is left. So please join for the next meeting just now, immediately at the same link. Okay, just join